Okay, today I'm here to teach you how to graph a rational function. This right here is the equation we'll be using today. So the first step is simplifying the equation. So what we did is we factored x out of the numerator to get this equation here, x squared minus 3x minus 4, but we saw that could be further factored into x minus 4 times x plus 1, and with the denominator we pulled out 2x and to get 2x times x minus 3. And then we saw that there's an x in the numerator and denominator, so we canceled that out. And so that becomes important when we're finding the whole. And the whole is a point in the graph where when you plug that value in, the numerator and the denominator equal to 0. To find the whole, you take what you pulled out of the equation, which was x, and set it equal to 0. So x equals 0. And then we plug that back into the simplified equation right here. And we got 2/3 is the y value, so our whole is 0, 2/3. And then the second part is finding the x-intercepts. So what we did is we used the simplified equation, and so we multiplied the denominator times 0, so we got 0 equals x minus 4 times x plus 1. We set that both those equal to 0 to get 4 and -1 as our x-intercepts. And then for the step 3, which is the y-intercepts, we set the equation equal to 0, and we solved for the y value, and we got 2/3 again. And then with step 4, what we did is we had to find the vertical asymptote. The vertical asymptote is a line that in the end behavior, the equation approaches but never crosses. So what you do is you set the denominator equal to 0 to find that. So we got 2 times x minus 3 equals 0. And so we divided both sides by 2, and we got x minus 3 equals 0, add 3 to both sides, and x equals 3.
Okay, so now we're going to talk about, as you talked about the vertical asymptote, now we need to talk about the horizontal asymptote. The horizontal asymptote is where the line of the function, it can cross it at the middle section, however it cannot cross it at the end behavior. So right here we have a couple things. Referring to this right here, this example, no numerical values, just a, b, x, and m. So n is the top exponent, the larger one, and m is the lower exponent, or it could be flipped either way. So a couple of rules here. So if n is less than m, the horizontal asymptote, which I just defined for you all, will occur at y equals 0. If n equals m, in this case, you would use the y horizontal asymptote would occur at a over b. So whatever the a value is, the numerical value, and the b value. Finally, if n is greater than m, there will be no horizontal asymptote. So none of that. But, however, if n equals m plus 1, which we'll get into later for this function actually, there will be a slant asymptote. So going over here, working out the horizontal asymptote, which there is none because it equals, n is greater than m. So now we're going to find the slant asymptote. So here we have to use long division, which we got into before. So you take the numerator and put it in between inside the lines and put the denominator outside. And so it's simple long division here where you take 2x squared and you have to fit into x cubed. So we do that by putting 1/2 x. You multiply that, you get here. Then you also have to multiply this number by this one. So that would get -3x squared. And then like simple long division we did with other values, you just subtract it all. So this equals 0. This would equal 0 because the negative sign would distribute to this sign, make it positive. -3 plus 3x squared. -3x squared plus 3x squared is 0. And then finally the -4x just drops down. So as we have the slant asymptote with a remainder of -4x. In this case, however, the remainder wouldn't be helpful for our final product, as we just want the slant asymptote. And as you can see here, it's actually a fraction. It's always going to be a fraction usually. It's a slope, so rise over run, as we know. So when you graph that over here, it'll be rise one spot, rise one value, one y value, and you go over two x values. So when you graph it, you have to put all the intercepts, y-intercepts, wholes, and as you know, we know the whole is at 0, 2/3. So you have to make sure it's an open circle because that's where the function will cross at some point. The x-intercept is -1, and then the other x-intercept is 4. And then going back to the slant asymptote, like I said before, it's rise over run, so rise 1, and then over 2, and then the vertical asymptote is going to be 3. And for any asymptote, you don't do a dotted straight line, you do dotted lines to make sure that it's clear to the user or viewer, whoever is looking at your work, that it's clear those are the asymptotes. And then here, we basically just go through all the points, and you cannot cross either of these points. All right, so it's pretty obvious that it's going to have to be this way. So we know that each lines go up as they extend. It's gonna have to go through the hole, and then it's gonna go through the -1 as the x-intercept. So that's the one portion that's going up for infinity, going there. And then on this one, it's the same thing. It's gonna cross here at the 4 of the x-intercept, and then continue going up and down. And adding on to that, you know it, there can never be a function up here or down here because it wouldn't pass the vertical line test, which is basically you cannot have a function. If you do a dotted line like this, you cannot have a function going the same way because that would be two functions with the same x value.